Good afternoon, class. We are looking at exam for review, chapter 4, application of differentiation, chapter 5, integrals, and here's part 4, covering 5.4, indefinite integrals, and the net change theorem, 5.5, the substitution rule. 5.4 in indefinite integrals and the net change theorem. According to the net change theorem, the integral of a rate of change is the net change. The integral of a to b f of x dx, or the integral of a to b capital F prime of x dx, which is capital F of b minus f of a. This is the first. Well, this is one of the fundamental theorem of calculus. Okay, and reminding you of some of the formulas that were the antiderivative or integral uh, formula. So to start with this, we are going to change square root of x to the power of 1/2. We make up two fractions, this one and this one. This is one, this is another one. And x has exponent 1 when we don't see an exponent. 1 minus 1/2 makes it 1/2. So x to the power of 1/2 plus x to the power minus 1/2. And now we use the power. 1 over 1/2 plus 1, x to the power of 1/2 plus 1. Plus 1 over negative 1/2 plus 1, x to the power of negative 1/2 plus 1, and a constant. And I'm going to box this, reminding you this is the only calculus step. Everything we've done so far and everything we do afterwards, they're all elementary algebra. 1/2 and 1 adds up to 3 halves, negative 1/2 and 1, positive 1/2. 1 over 3 halves is 2/3, 1 over 1/2 it's 2, and this is the final answer. So notice, we change this one, 1, and then 2, and 3, and 4, and 5 steps of algebra, 1 step of calculus. A bacterial colony increases at the rate of R of t equals 2.t e to the power 0.4 t bacteria per hour. If the initial population is 800, find the population after 12 hours. So what do we need to know? If capital R of t represents the population and capital R prime equals lowercase r of t represents the growth rate, that's exactly what this means, the derivative function. We have the initial value R of 0 equals 800, and therefore the accumulated change, the amount of increase in population after 12 hours, is the integral of 0 to 12 lowercase r of t dt. There are two ways to approach this. We're going to look at both methods in a moment, but for now, let's replace this. In the case of exponential, we multiply by k for differentiation, we divide by it. So we're going to divide by 0.4 in the case of integration. And this is 22 divided by 4, or 5.5. You evaluate this by plugging in 12 and then 0. So 5.5 e to the power 0.4 times 12, or 4.8, and this is e to the power of 0 or 1. And you plug it into a calculator, it gives you a number such as this one. And because we are looking at the population of bacteria, we are going to go with the whole number. And when you go with the whole number, you just do the rounding accordingly. This is 8. therefore it goes up. Don't forget, this is the amount of increase. We initially had 800, and we are going to add this, and now we have 1463. So R over 12 after 12 hours is this what we found as an increasing amount plus the initial. The second method is not to use the 0 and 12 and just integrate that. We've already done that. It's 5.5 e to the power of 4t and a constant. So this one has a constant. But we have the initial value R of 0 equals 800. We can plug in and find the value of C. So R of 0 is 800, 5.5 times e to the power of 0 plus a constant. As you know, e to the power of 0 is 1. So 5.5 plus what number is 800 is 794.5. And your function becomes R of t equals 5.5 e to the power of 4t plus 794.5. So you can find R of 12 or R of 15 or R of 10. You don't have to go through the process. The advantage of this is that at any given time, you just plug in the t. In this case, if we plug in 12, we must and we will get the same value, everybody. So it's pretty straightforward. Let's continue integrating sine of 2x over sine x. The technique is to rewrite this as 2 sine x cosine x. Okay, you remember sine of 2x is 2 sine x cosine x, okay? And so you have 2 cosine x dx. The derivative of cosine is negative, but its integral is positive. So 2 sine x plus a constant. The integral of cosine is sine. So 2 sine x plus a constant, and you're done. The integral of dx over x as we approach it from 3 to 6, first and foremost, notice this is just in case 1 over x dx. So that's a natural law. And you plug in the upper and lower limits. You can leave it like that, or you may notice is ln of 6/3 or ln of 2. Many fish grow in a way that is described by the von Bertalanffy growth equation for the fish that starts life with a length of 1 centimeter and has a maximum length of 30 centimeters. This equation predicts that the growth rate is 29 e to the power minus x centimeters per year, where x is the age of the fish. How long will the fish be after 4 years? And then you round it. So this is the rate, the growth rate. This is the derivative. So we let L of x represent the length of fish at age x. Then the growth rate becomes this derivative, L prime or dl dx. So L prime or dl dx is this. And the initial value is that it's 1 centimeter. So L of 0 is 1. That's the initial value. Again, there are two ways to do it. I'm going to look at both of them. The amount of increase uses the net change theorem, and it's going to have the integral of 0 to 4 of this function. You're dividing by -1, you get minus 29 e to the power minus x from 0 to 4. You plug in, you can take the -29 out, e to the power minus 4, e to the power of 0. And e to the power of 0 is 1, but you have to use a calculator here, and you use that, and you end up with the following 28.4688. You don't want to do any rounding in mid steps, just at the end. And so this is the amount of increase, and L of 0 is 1. Add to it, you get 29.4688. Now it says 1 decimal. Next to 4 is 6. You take it up, you make it 29.5 centimeters. And that's fine, and you're done. Everything is perfect. I just want to show you a slightly different method as we did in the previous example. So what we are going to do, we are going to find the derivative without paying any attention with the limits. So we get this one and a constant. And it's an initial value problem because we know L of 0 is 1. That will help us find the constant. So L of 0 is minus 29 e to the power of 0 minus 0, which is the same as 0 plus c equals 1. As you know, this is e to the power minus 0, or 0 makes no difference, 1. Minus 29 plus what number is 1? That's number 30. So c becomes 30, everybody. Okay. Now, what do we want? L of 4, and that gives you exactly the same answer as this guy, as it's supposed to. Okay. So it's pretty straightforward. The advantage of this method, if they want the length of the fish after 5 years, 6 years, 7 years, you just replace it here. Otherwise, you have to keep on calculating the amount of increase and add 1. Example 37, a particle moves along a line so that its velocity at time t is v of t equals t squared minus t minus 6. And it's in meters per second. Find the displacement of the particle during the time period 1 to 4. Let's look at a couple of definitions. Distance equals the integral of absolute value of v of t as we go from t sub 1 to t sub 2. So this area under the curve, which represents the distance for this one, this one, this one, they get added up. Okay, that's distance. However, displacement is without the absolute value. A1 and A3 are considered positive because they're above the x-axis. A2 is considered negative because below the x-axis. So we have A1 minus A2 plus A3. That's the idea. In other words, one easy way to understand this is as follows. If we want to go from point A to point B, and if we go like this, we cover the distance of this much, plus this much, plus this much, plus this much, plus this much. All of them must be added. That's distance. But displacement says I just went from A to B. This is the displacement. So the red one is the distance. The blue one is the displacement. So for this one, we want s of 4 minus s of 1, and we want the integral of v of t dt, which is simple. So I'm going to erase my work, plug in, and this is 1/3 t cubed. This is minus 1/2 t squared. This is minus 6t. And by now, you know how to evaluate it. Plug in 4, plug in 1, and we end up with negative 9/2. So displacement can be negative or positive. Okay, so if you have a direction, to the right is positive, to the left is negative, so displacement can be anything, but distance is always positive. And now we want to find the distance. So the particle moved 4.5 meters towards the left. That's the idea of why it's negative. Class negative 9/2 is the same as 4.5. Why meters? Because the units were given here as meters per second for the velocity, and therefore 4.5 meters. Okay, everybody? All right. Part B is asking for the same thing, but this time distance instead of displacement. Therefore, it's the same integral, but the v of t is in an absolute value. So what's the difference? The difference is you have to know where this function v of t is positive and where this function is negative. So this function must be factored, and you want two numbers. The product is -6, the sum is -1, is positive 2 and -3. So you factor it as t plus 2 times t minus 3. You must use a sign graph. So I have a number line from negative to positive infinity. Actually, because we are dealing with time, you can go from 0 to infinity, okay? But either way. And you want to figure out where it's positive, where it's negative. We are really interested from 0 to infinity, okay, class? But the sign is very simple. If you pick up TPs, this is the sign graph. Everybody knows it by now. TP short for test points, okay? Over here, you can even pick 0 if you want. Over here, you can pick, for example, 4. This is not important because we really start from 0, okay, because of the time. But in any event, so if you plug in 0, and it's easier to go with this one, you get negative. If you plug in 4, it may be easier with this one. It's 6, and this is 1. Positive times positive makes it positive. But they will alternate. The reason they will alternate because this has degree 1, this has degree 1, which is the odd degree. This is positive. We are not interested in that. So absolute value of v of t dt from 1 to 4. We want it really from 1. So because the change happens at 3 and from 1 to 3 is negative, we have to go with minus v of t, and from 3 on to infinity is positive. That means from 3 to 4, we just use v of t. So one more time. We want from 1 to 4. We did the sign graph from negative to positive infinity. You can do really from 0 to infinity. You can even do from 1 to 4. So from 1 to 3 is negative. In this vicinity is negative, so 1 to 3 is negative. You have to negate that to make it positive. Beyond that is positive, 3 to 4. So this becomes the same thing. Negate that, minus t squared plus t plus 6dt from 1 to 3. And this one, you just like this one, you put it in. So this is negative 1/3 t cubed plus 1/2 t squared plus 6t. And you evaluate it from 1 to 3. This one from 3 to 4, 1/3 t cubed, just like the other one, right? Minus 1/2 t squared minus 6t. And you really have to take a little bit of a time to evaluate. Plug in 3, plug in 1, subtract them, plug in 4, plug in 3, subtract them. And we end up with 61/6, precise answer, roughly 10.17 meters. So the distance is always positive. Displacement can go either way. So distance will add all of those. Displacement will consider this one as negative. Difference between the value of definite integral and total area. That's exactly what we were discussing in the previous page. Find the area between the x-axis and the curve y equals cosine x from 0 to 3 pi over 2. If you want the area, you have to go with the absolute value of cosine. Because this is above and is considered positive. This is below and it's considered negative, everybody. This is positive. This is negative. This area, positive. This area, negative. If you want the area, you have to go with the absolute value. If you do not put the absolute value, it gives you the definite integral which represents difference of areas or signed areas. All right. Because it's positive here, just cosine x. Because it's negative here, minus cosine x. So from 0 to pi over 2 cosine x, from pi over 2 to 3 pi over 2, because it's negative, negative of that. That's the nature of absolute value. And each one is sine x. This is sine of pi over 2 minus 0. This is sine of 3 pi over 2 minus sine of pi over 2. So this is 1, this is 0, minus, this is negative 1, minus positive 1. So this becomes negative 2. With this negative becomes positive 2. With 1 is 3. Okay. So let me just write this so everybody can see what I'm doing here. So this one is 1 minus negative 2, which gives you positive 3. But if I'm asking for the value of this definite integral 0 from 0 to 3 pi over 2 of cosine x dx, then what happens is that this is positive, this is negative. So this is 1 and negative, they add up. In other words, positive 1 and negative 2 add up to negative 1. So the answer is negative 1. Or show it, sine x from 0 to 3 pi over 2. Sine of 3 pi over 2, you should know it's negative 1. Sine of 0 is 0, so it's negative 1. Again, or this area, class. This area is considered, this area is equal to 2. This area is equal to 1. When we are interested in the area, we add 1 and 2. But if we are interested in the definite integral, then it's 1 positive, 2 negative, because it's below the x-axis. 1 minus 2 becomes negative 1. You can see that. So you want to be able to distinguish between the two. The substitution rule, integration by substitution is the reverse process of the chain rule in differentiation. So recall, if we want to differentiate this, what do we do? Capital F prime of g of x times g prime of x. And capital F prime, normally capital F prime is lowercase f. So f of g of x, g prime of x. If you let u represent g of x, then du dx is g prime of x and du is g prime of x dx. So the integral of f of u du is capital F of u plus c or capital F of g of x plus c. In other words, over any interval for which u equals g of x is continuously differentiable and f is continuous on the range of this function, the following relationship holds. The integral of f of g of x g prime of x dx, this is u, this is du, it's f of u du, or capital F of u plus c, and u is replaced by g of x. In other words, you do the substitution when things get a little bit involved. That's all there is to it. So let's practice with this methodology, everybody. I want to differentiate this, and the process is to use the substitution. If this, I mean, let's say for the sake of argument, it says to the power of 3, you can probably raise it to the power of 3, but there it's difficult. That's why we need to use the substitution method. Use the substitution method when polynomials are involved. The more complicated one normally is the choice of u. So x squared plus 5 is the choice of u because it's more complicated. And if you differentiate it, you get du dx is 2x. Let me just write that so you can see du dx equals 2x. But that's not what we want. We want du, which is 2x dx. To make sure it's clear to everybody, we are going to move the 2x next to dx, and therefore this entire thing is du. This is u to the power of 30. Now this is an easy integration or anti-differentiation. We use the power rule. So we get 1 over 31, u to the power of 31 plus a constant. And u is replaced by x squared plus 5. And as always, you can check if you differentiate this, you should get the original one without the dx. In other words, you get the integral. In this case, we just do it term by term. First of all, the independent variable is theta, so 5 doesn't give you 5x, gives you 5 theta. Then cosine, the derivative is negative, but the integral is the positive sign, so plus 2 sine theta and a constant. The integral of x to the power 4 is the power of x to the power of 5 minus 2. Now, anytime you have an exponential in conjunction with x or powers of x, the methodology is to use substitution, and the choice of u is always the exponent. So u is x to the power of 5 minus 2. As you know, the derivative is 5x to the power of 4. Therefore, du is 5x to the power of 4 dx. So first and foremost, I'm going to move x to the power of 4 next to dx. Secondly, I want to go back to this, and I want to tell you what others do. Normally, they solve for dx. I'm not going to do that. Here's the easier way, everybody. When a number, a coefficient, a multiplier is missing, you can just multiply it by that. If I throw in this one, then I can multiply by its reciprocal to undo it. So I put a 5 here times 1/5. I put the 1/5 out. It doesn't matter. What did I throw in? Any number and its opposite. The product of these two numbers must be 1. And this can only be done with numbers. In other words, let's say I'm making something up. Let's say x is missing. You can't do that. Okay. So it has to be a number. So you're looking at e to the power of u du. So this is u. This is du. But the 1/5 outside remains. It doesn't go away. And the integral is 1/5 of e to the power of u and a constant. And u is replaced with x to the power of 5 minus 2. We are done. And as always, when you have time, check by differentiating this, it must give you this one without the dx. So a quick recap. When you write the du, in many cases, they solve for dx, so that becomes du over 5x to the power 4, and they can get rid of that. It just takes longer. You can do that, yes. I don't like to do that because it's a lot easier for me to notice, okay, number 5 is missing. I put the number and it's reciprocal. By the way, it doesn't matter where you put them. So it's ultimately, it's a multiplier. They get multiplied. How about this case? Let's start with a fraction and explain something. Number one, you have to make sure the fraction in its lowest term, because if there is a common factor between the top and the bottom must be dropped. So a quick checking, we notice the denominator is 2x plus 3 times x minus 1. I'm assuming nobody has any problem with factor. So nothing cancels out for this case. And when that happens, when you have a fractional rational function, a fractional format of this form, it is always the denominator which is a choice of you. Again, step one, factor everything. Can you simplify your rational function? Step two, we can't. The denominator is a choice of you. So if I differentiate, I get 4x plus 1. So du is 4x plus 1 times dx. Please understand du dx is 4x plus 1. So du is 4x plus 1 times dx. And to make sure we understand what's going on, I'm going to put the dx at top next to 4x plus 1. So now I have du over u, and this integral, we know that the integral of 1 over x dx is natural log, so this one is also natural log of u and a constant. And you replace the u, and you're done. That's all there is to it. And you keep it in an absolute value. By the way, if this function ends up being positive, you can get rid of the absolute value, put it in a parenthesis. So why did I put A and B on the same page? What is the similarities between the two? The denominator is the same, but the numerator over here, I can factor the 4 out, and I can simplify the fraction. That's the difference. So again, I can't simplify, I must. So we write the simplified version and deal with that. So you're dealing with a fraction with with a rational expression. You let u be the denominator. So du dx is 2, or du is 2 dx. So if I put the dx up here, I have 4 of them, but I need only 2 of it. So I put the 4 as, so I just write this one as 2 times 2. That's all. And I take one of them out. That doesn't matter. You can keep it inside. My point being, the numerator is 2 dx or du, the bottom is u. So these two, even if it were here, big deal. It's just a coefficient. And this is just like that one is a natural log. Now, number 2 remains, and u is replaced. And the final answer is 2 natural log of absolute value of 2x plus 3 plus a c. And you're done. It's that simple, everybody. Again, I put those next to each other so you can be exposed to both and see how we handle them. Okay, everyone. And it's pretty straightforward. Now, I'm going to write the reciprocal of part B. Take a look at part B, everybody. And I'm going to write the reciprocal of that because I want to show you that you don't have to assume you need substitution always, but you do need the same process of simplification. Remember, we got this one, we got this one, so this one is the reciprocal of that. I'm assuming everybody is following what? Factor the top, factor the bottom, and this is what you get. You don't need a substitution. This is 1/2 x, this is 3/4. I hope you know x is half of x squared, with this 1/2 is 1/4 x squared. This is 3/4 x and a constant. The point being, we need a substitution, yes. We need a substitution, yes, but before that we have to simplify. This one we need a substitution. No, you simplify and you recognize that if you make up 2 fractions, you can easily come up with the answer. The integral of e to the power of t over 5 plus e to the power of dt, and I want to discuss them in a moment, and similarities and differences. Anytime you have a rational function or a fractional format, the very first step is, can I simplify? And in this case, the answer is no. Because you can't, the choice of u is the denominator. If you differentiate du dt becomes e to the power of t, therefore du is e to the power of t dt. We put the dt next to e to the power of t, so it becomes clear that we have du over u. So the integral of du over u is the good old natural log. Replace the u, you get natural log of absolute value of 5 plus e to the power of t plus a constant. Over here, because the expression 5 plus e to the power of t is positive, you can just use parentheses, okay? Either way is fine. What about this one? You want to factor the denominator, it can't be done, so you choose that to be u. Now, if I differentiate, I get 2x plus 2, 2x plus 2. So du is 2 times x plus 1, or 2x plus 2 times dx. So I factor out the 2 out. The reason I'm factoring this, because I want to put this at top and show you that the denominator is u, the numerator is not du. Instead, if I plug in 2, I can put the 1/2 out. The product is 1 and I'm fine. Or you can see this, you can say this is half of du, either way. So now you're looking at 1/2 the integral of du over u. And again, this one is the good old log. So 1/2 natural log of u and a constant. Replace the u and you're done. Of course, you have to keep the absolute value because this expression can be positive or negative. Whereas this one, it can't. It's always positive. Now, again, for practice, I'm going to look at the reciprocal of this guy because I want you to see the difference between the two. In this case, we choose the denominator as a choice of u substitution. However, in this case, we don't have to do that because this is a different color. This is 5 e to the power of negative t, and this is 1. There is no need for substitution, everybody. No need for substitution. So what's the answer? This one, 5 divided by negative 1 makes it minus 5 e to the power minus t. This is t and a constant, and we've done. So no need for substitution. What about this one? The integral of square root of 3x plus 7 dx. Now, it's a question I want to do both ways, the way that I do it and the way that most texts do that. You'll see what happens. First and foremost, the choice of u is 3x plus 7. Du dx is 3, therefore du is 3 dx. Now, what others do, okay, and I'll show you my way also. What others do, they solve for dx becomes du over 3. Solve for dx. And so this now becomes square root of u, and this becomes du over 3. The reason I chose this one, because this is simple enough, really doesn't make much of a difference. If it's not simple, the method that I showed you, it's a lot faster. So we put 1/3 u to the power 1/2 du, and we finish the job. However, what did I do? I would say this is square root of 3x plus 7 dx, and I notice number 3 is missing, everybody. So I look at this one, and I say number 3 is missing. I put a 3 here, and I undo it with 1/3. This is what I do. So please understand, this is square root of u, and this is du. So that's the same thing here with the 1/3 in front. Okay, I think it's a lot easier to go this route. In this case, maybe not much of a difference. So again, notice this one is okay, square root of du or u to the power 1. This one remains. This is 1 over 1/2 plus 1 u to the power 1/2 plus 1 and a constant. 1/2 plus 1 is 3/2. So 1 over 3/2 is 2/3. This is 2 over 9. And you replace the u with 3x plus 7. And we are done. You can use the same, you put under the radical if you want. You don't have to. It's not that big of a deal in this case. If f of x is 4 e to the power of negative 0.2x minus sine x, we want to differentiate. And we want to integrate. I want to remind you the differences. So 4 remains. The same thing is the derivative, and you multiply it by negative 0.2 minus cosine x. So one more time. 4 is a multiplier. You write the same thing and you multiply by the coefficient of x. This is cosine. We are going to rewrite this as negative 0.8 e to the power minus 0.2x minus cosine. So that's differentiation. Integration. So you have to have a dx, okay, class, because the independent variable is x. Now, in this case, we multiplied by this number. In this case, we divide by it. So 4 divided by the coefficient of x negative 0.2 e to the power of negative 0.2x minus sine becomes plus cosine, because the derivative of sine is cosine, but the integral is negative cosine. With this negative makes it positive and a constant. And this is 40 divided by negative 2 makes it negative 2. So capital F of x, because we call this lowercase f of x. So this is capital F of x is minus 20 e to the power minus 0.2x plus cosine x plus a constant. And that's a general solution. What if we made it into an initial value problem by letting capital F of 0 be 20? Just making up some number. So in that case, you're going to replace the x with 0 and f of x with 20. So let's see what we get. You know this is 1, you get minus 20. Plus cosine of 0 is 1. Plus c equals 20. So as you can see, the left side is negative 19. Move it, make it plus 19. And c becomes 39. So the general solution, now if you replace the c, becomes a particular solution, and therefore the initial value. Minus 20 e to the power minus 0.2x plus cosine x plus 39.